Hello and welcome everyone, this is Dmitry. We are having another network programmability stream. Today we'll continue working on our project with building a network automation controller. I call it NetWarden. And today I think it's going to be part 5. We will be focusing on network diagrams today. So I want to have diagrams directly in my network controller. We built some of the pieces required for this last time and also on some previous streams. In particular, I already had a stream called Build a Network Diagram using LLDP information. And also we were exploring Vue.js to actually display diagram on a web page using JavaScript. So by combining these two pieces together in my application today, I think we should be able to achieve the result that I want. And I'm planning to have at least 2 diagrams. I want to have expected diagram, and this is expected is based on the information in the netbox. So because you put like connection there and stuff. And then I want to have an actual diagram. That diagram is based on LLDP information, and it needs to be displayed on the web page, on our controller page, pretty much. Before going into that though, let's discuss a couple of things that I want to discuss for the stream. And by the way, if you're watching this as a recording, there is almost always a time code below in the description on the YouTube. And so if you don't care about some pieces, you can just jump between sections very easily, okay? So first and foremost, there will be Cisco Live virtual event on, is it 2nd and 3rd? Yeah, it's June 2nd and 3rd, so it's what? It's Tuesday and Wednesday. Okay, and there are going to be a bunch of sessions. I will be listening to some of them since I'm interested in some of the like announcements that are going to be made. So, and this is for free, so you just can go ahead and register for this. Now next there will be a separate DevNet day on right after Cisco Live US, and this is the correct link, I guess. Oh, actually the agenda is here. You do need to register, but it's also for free, and there is going to be a bunch of sessions during one day on different tracks. So you can see agenda here. There will be like keynote, and there will be sessions for different tracks from lunchtime till the end of the day. Now I'm probably the most interested in this, and in my previous DevNet Create event, which was last year, Demo Jam was probably my most favorite part, and this was like on the main keynote stage. You could show like a demo within 5 or so minutes. It's kind of like lightning talk / demo, if you will. That was really a lot of fun seeing different stuff that people built. So I'm really looking forward to Demo Jam on this DevNet day. Okay, so 2 events. So it's Tuesday, Wednesday, and then DevNet day is on Thursday. Next is David Beasley, a very famous person in Python community. He does a bunch of conference talks and trainings and stuff like that. And so what he did, he released his course that he's doing, I think, like in corporate environment and stuff for free. So it's called Practical Python Programming. Where is this? No. Here. Okay, so it's Python course. It's not for like beginners. You need to have at least some kind of understanding of some of the things, but from there it will take you to like through a bunch of different topics, like how to build your programs and what generators and classes and logging and debugging and stuff like that. So I didn't go through this course at least yet, but I'm 90% sure that this course is going to be very cool, because David produces a lot of amazing Python content. Next is Anthony Shaw here on the list. So Anthony Shaw, also very famous person in Python community, and he was working on this book for a really long time, and it's right now available as an early access. It's called CPython internal. So if you want to understand what's happening behind the hood of CPython, like how it deals with memory and how its interpreter works, and probably understand GIL a little bit better, or global interpreter log and stuff like that. And yeah, I can definitely recommend taking a look at this book, so you can get it via early access right now. Cool. Next one is Lucas Schlanga, and he's employee of HDB, and he is recording a free asyncio course, and it's still like work in progress. So if you look on YouTube for HDB, you will go to their channel, and they only have these 3 videos there in playlist. There should be 7 videos total, so he's still working on the rest of them. But I have already watched all 3 of these, and they are really great. They go very deep into what is happening in asyncio and gave me a lot of understanding, a lot of ideas. If you're like super new to Python and super new to asyncio, you probably want to brush on that first and like read something and try something first with asyncio before you go through this course. But it is really a good resource, so I can definitely recommend it. I'm really looking forward for the rest of the series, for the rest of the for the remaining 4 videos. And last but not the least is Carl, and so Carl Montanari. We had this stream with him last week. Well, no, 2 weeks ago, because I didn't have a stream last week. And Carl, we were discussing his library called Scraply, and if you haven't watched that one, among all of the recordings that I have, I would probably recommend watching them. I feel like, I don't know about others, but I really liked it. I really liked like where discussion was taking us and stuff that we were trying live with his library and discussing why this is good or bad design. So I can definitely recommend watching the stream. But one of the things that he started working on right after the stream was asyncio support in his library, and actually in one evening he managed to add it. It's still very beta, so Scraply asyncio. Oh, and we have Carol in the chat. Very nice. Hello, Carol. So I think if I go to GitHub page, right, and I think you told me that it was yeah. So there is a branch for async, and I haven't tried it yet, but Carl told me that it made it work with ISXT. So I'm very curious to see that, and it's actually going to be very interesting for our purposes for this network controller project, because if you folks remember last time we were building RESTCONF integration, right? And the natural step from there is to add support for other mediums like like SSH, like netconf, for example, because not everything you can pull via RESTCONF, for example. So, and everything there in my controller is async. So actually using that is, yeah, well, I want to give it a go. Probably not today, but yeah, something like I'm very curious about this. Like if we can make it work with my controller, that would be very cool. All right, that's all I have from like extra topics. Now we will go to the main topic today. Let me also check the chat. What is the level of this video? Beginner, intermediate. So okay, so I think you talk about these three. Our author claims it's for asyncio beginners. I disagree. I think it's for intermediate level. Like you need to have some kind of asyncio expertise, at least something to kind of understand, because you'll probably get lost very easily. If you're looking for something like this, I can recommend two things. And let me try remembering it. So first I would go and watch, is it by Bay? Raymond Ettinger? Yes, this one. So first this would be the very first step. You would watch this keynote on concurrency and understand what problem asyncio is trying to solve. So it has example of like threading and asyncio and stuff. The next step would be, how it's called, sync techniques, I think. Yeah, I think this one. Yeah, so then you would go to Talk Python, and they have a course for 48 bucks, 49, which go through like threading and multiprocessing in asyncio and very basic async web applications. And it's course by Michael, also very famous person in Python community. I went through this course. I think it's very good. It's not very deep. So this is something that, let's say, anyone with Python knowledge without any async experience can understand and can learn a lot from. So yeah, I would go through this, then I would go do this, and then I would do this. And obviously you have to do your own hands-on on these topics, because otherwise like you will get lost pretty easily. All right. That was all from this all extra topics. Let's get into the main topic. So today we will continue working on our controller, and I want to add diagrams. And as I said before, we already did all of the work on previous streams. So really, today we will like try to glue everything together, I guess first that I want to start with, and probably I can close all of this, it's not relevant anymore. Okay, I want to make sure I can connect some of the devices, which I can. Cool, so then next step is what? Next step is I need to open my project here in VS Code. Thanks for the suggestions. Sure, you're welcome. Just make sure you do your own hands-on, because I think it's not something that you can read about and understand without trying. It's true for most of the tech topics, but for asyncio it's something that is even more true, I guess. Let me see what was that. Very nice. Cool. Okay, so let's see. I think I will need another one here. If only I remember it. I really don't remember some of this stuff. Like, you don't work on the project for 3 weeks and then, like, what is going on? Okay, I just started as a demon. Okay. 80. Okay. Give me 1 second, folks, here. Okay, I'm back. I'm trying to remember, but my memory doesn't help me today. I was curious, what is this check remote that is terminal? Hello? No, it doesn't work. Okay. I think I had task file here somewhere. Yes. So, oh, I actually have here netbox backend and frontend. Okay, so I need split terminal. And I need task backend, I guess. And I need task frontend. It's good that I added this because then I would try looking for this command somewhere. Okay. So my frontend is on 8081. And I will probably need to get rid of this, but work on this. Okay, look at this. So, and I probably need to delete this session key here. Maybe I should say session key was retrieved here instead of showing the key. There were 3 responses, 200 okay, and then search devices was 200 okay. Okay, cool. So this is what I expected to have. This is what we did last time for this project, right? And so let me kind of brief you what is going on here. So I have these devices. Those are fetched from netbox. The site is fetched from netbox. Then this one is kind of built dynamically. So we take the device name, we take a slug name for the site, and then we add the suffix labdmfigl.me. So ideally I want to have DNS server which will resolve this to to the management IP address. So then I have vendor. In here I have model. So I think both of these, I don't remember. Yeah, I think this is from the netbox. Now the software version, this is interesting. So the software version, we actually, for the software version, where is this? So for the software version, I created here a function which will extract it from the RESTCONF query for device hardware, device system data software version. So this is fetched via RESTCONF, and then we parse that because like it doesn't give you exactly 1611 something. And then we also get serial number here. So these two pieces of information are fetched via RESTCONF, and you saw how fast that was. It took like a second or so, but it still was very fast. And then like once we continue building on that, what I would do is that for these slash devices, I would have it in the cache, I don't know, for like 5 minutes or so we don't fetch it all the time whenever you refresh this page. I can actually refresh this page right now. You saw how fast that was, even considering that we get these two columns directly from the device using RESTCONF. So then this one we take from netbox secrets, and this one is static right now. We'll have to like add consoles at some point. So then the next piece that I want to do is that I want to have here a new link called network diagram, and under it I want to have another two links, like I want to have expected diagram and an actual diagram. So this is what we are going to work on today. Now, in order to do that, you will be reusing some of the pieces. So there will be two main things. So we'll be using this thing that I built a couple of months ago, visualization of network diagram using JavaScript. So we'll be using this. And again, I barely remember how to do that, but I guess we'll manage. Yeah, so we'll have to I have to think about it. We'll be reusing this work, but also we can reuse another piece. And I'm thinking like how to do it correctly. So if I go to here, right, and then there was RESTCONF, I think. Wait, where is it? No, no, no. It's in Nornir, yeah. Not Nornir network diagram. So we may be reusing some of these pieces, or probably I will have to write it from scratch. It's going to be a little bit easier. I could definitely leverage some of this, but I have to think about this. And I think I actually want to start this LLDP here. So let me think what we want to do. And I think the first step would be to use Postman to look in our LLDP data again. And what is the endpoint for this? No. Okay, so constant OpenConfig OpenConfig slash LDP slash interfaces LDP faces. And I guess I will have to enable LDP everywhere. I think it's enabled. Okay, so I can use this. Now let's see what how do we get the data? Okay. OpenConfig LDP interface. This is a list, right? Then we have interface is config and state. So this was the first interface, there's nothing there. Now on gigabit 2 there is nothing. Is this even correct? Oh yeah, on interface 2 there is nothing. So then interface 3 is connected to 2 and interface 4 is connected to 4. Okay, so this one is useless. 3 on 3 there is neighbor, right? And then you have a neighbor. On each you have a neighbor system name, so we'll have to strip this suffix here and this port description. Wait a minute, I didn't know you have a port description like this. Okay, so we have this one, we will need this one, management address. Okay. Okay, so I want to retrieve this data. I will have to create a handler specifically for OpenConfig. This should convert it to objects. Now I need to understand what kind of objects you want, right? I guess I want to have, and I think for this I will need to refer to what JavaScript expects. So let's take a look at that. So JavaScript Vue.js expects the following data. So it expects just nodes with their IDs, right? Like you have 10 nodes. Just nodes, which is fine. We can already get this information super easy from netbox. And then edges. You have to connect. Okay. So I guess I will have to create, I don't want to create ID. Or actually we can create ID, it's not that hard. So I create an ID and then you have to do a connection from one node to another. And then we need to have a title for that. Okay, so I guess I want to have two type of objects. I want to have node and I want to have edge, right? Or link. I will call it link for networking terms. So node and link. Link should actually refer to the device objects, and then we can create. No. I'm thinking what is the best kind of object model for this. I'm still not sure. So I guess I want to have class node. So this will have a name and an ID. So name, ID. Interfaces, question mark? I don't know. So then the next piece probably is interface class. And I guess that node will have these interfaces as a thing. And then, well, yeah, I guess. So then, yeah, we'll have interfaces, which will have this interface. So interface will have a name, and pretty much that's all we need for this, right? We just need a name for the interface. We also have a slug for this. So slug name is like from Gigabit Ethernet 1, we converted to GI1 something, right? So it's easier to read this. And then the next will be link, right? So this one, damn. God damn it. I mean, link connects two interfaces together. So it should have self.interface and two interfaces. Now, this is kind of where I see a potential problem. Oh. So if we have self interfaces here, right? Which is a list. Yeah, I can definitely see a problem here. Well, god damn it. So I'm kind of stuck here. I'm trying to formulate this correctly. So this self interfaces seems like a decent idea. This will have a list of these objects. Now, here is kind of a weird one. We need name and slug, but we also need to have a reference to node as well. And this is where what I don't know. So I guess we can just say node ID instead. And then we can look up the node. I think that's the only. So, well, no, that's not the only way. So we can either do this or node. But if you do node object, then you have a circular reference. And what this means is that you cannot create these two objects frozen. The benefit of using this, right, of this, is you can then say, so let's say you have interface G1, yeah, and this will be this interface object. The benefit of having node, then you can say G1 node name, which is cool, right? This is plus of this, right? But minus of this circular reference between node and interface, meaning can't create frozen classes. I don't know what is correct term for frozen stuff, but it's classes which have a data which is not mutating over the lifetime of the class. And I found for a lot of things this is actually a very good thing to do. Because if you have something that can be none or something else and you change it during the runtime, it can become messy. So if I use node ID, then I will have something like G1 get node, and I will have to provide ID to node, right? And then node ID is equal to node ID or something like this, and then I can say name. So folks, what do you think about this? Like, I hate when I encounter this, but I still haven't found the way that I would be super happy with doing. I mean, this looks so much cleaner, right? But this is also quite a big deal. So if you folks have any kind of insight on this, that will be helpful. I will check what I did for somewhere here. Okay, so I kind of cheated a little bit here. So I have a class interface where I just have a device name. In this particular case, this will not work for me. Because if you look on this data, right? So let's say I have a class called link or edge, doesn't matter. And then it contains it will be like this. I will probably even copy this because this is quite good, right? So link contains two or more interfaces. Yeah, I will definitely copy paste this. Okay, so this refers to two interface objects. Now, if you go back to and look on interface object has device name and type and number. So this one type is like gigabit Ethernet. Num is like 0/1 or just 1. Device name is, let's say, R1 or whatever, and then neighbors. I don't think we need neighbors. Right, this will not work for the stuff that JS expects, because I will have this, so I can do this, but I cannot do this, right? Because besides router 1, this one, I will also need device ID, right? And adding those two to the interface kind of doesn't make a lot of sense here. So what do you think, folks? I think most of this can be copied to my project, but you'll need to at least modify this one. This is interface py. Okay. So okay, one idea that I have, we're still thinking about this. It boils down to so ideas that I have, and where is this? I am leaning towards this, and we can avoid circular reference if we will not have interfaces here. Okay, so if node class will not have interfaces objects, then I think we could avoid this. So we create nodes based on just list of nodes, right? From netbox, for example, which we can do. And then so get nodes or something, right? Then for yeah, they will not have this interfaces thing. And then we'll go through RESTCONF stuff, right? And then we create first we create an interface object for every single interface where but ideally we want to create it for every single interface, not only for LLDP but for every interface. Though actually in this case it's actually pretty nice, right? Because this OpenConfig LLDP, if it's enabled on the device, it will actually give you a list of all interfaces where it's enabled or disabled, which is good, right? So we can go through this and create these objects for every device, right? So like I will be iterating through every node, and then we will be getting this and then creating a list of interfaces where we will be referencing this node class. The only problem is that where do we store these interfaces? Where do we store these interfaces? I think I should start building it and see how it goes. I don't have a clear picture in my head right now. So I may need to have some global interface dictionary. I don't know even. Okay, you know what, Fox? I will just probably just get it done, and I will start building. I'm talking too much today. Okay, so what do we do? Let's just do node. I will add the rest later. Okay, so because we will need an ID, right? So current ID. Yep, and then not current ID plus equal to 1. Yeah, okay, so I need name and I need ID. Now interfaces, I will do diction, probably a list here, and I will comment this out. Do I need this? Okay. Okay, so we have so we can create this node object, right? Based on the name, and then we will have an ID which will be like monotonously incrementing. Very cool. So then I will need this await on this netbox list. Very same thing, right? So I guess we want to do what? We want to let's do like this. Okay. And then async def LDP graph. Okay. Okay, so devices is equal to the same thing, right? Next, I need the function here, which we can add here, I guess, as a class side. Yeah, I think we can add it as a class method here. Which will be from netbox devices. This will be CLS, and this will be devices, which is a list of dictionaries of str any from typing import list dic any. Actually, where is this? Yeah, it's list of dictionaries. Okay, and this will return a list of node classes, right? So for device data, devices. Okay. So for device data in devices, we'll need the device, we'll need this. Yeah. And then we return out. Okay. So this will create this node objects, right? So this is the first step. Then for every device, for every one of these netbooks devices, actually I'm thinking about this. Could be generator instead, but I'm thinking if we will get anything by creating this as a generator. I don't think we will. But yeah. Okay, so here I fetch devices, yes, and then I say not netbox devices. Okay, so this will give us a list of things, a list of nodes. Now for every one of these nodes, I will want to connect and fetch OpenConfig LLDP, right? So I guess for node in nodes, I will have to add this request object here. We'll do the same thing like we did before. Something is bothering me here. So what this does, so this is get devices, right? So this is backend API for this view, more or less, right? What this does is that we get every object and then we create a connection for every device based on the management IP and the platform and some other stuff. Now, we set this a RESTCONF connection to the cache, and then we retrieve that using get connection, right? Now, in all other pieces of the program, you will have to reuse the same logic, right? We will have to do exactly the same thing. I would want to create a RESTCONF connection if one doesn't exist. But when I need to do that, I need to query netbox again, right? For management AP, for username, for password, stuff like that. What is this function doing? What is this? This is so ugly. I don't know what is happening here. Super ugly. So I can do a shortcut here, but I don't want to. So I can just say this, right? I can just get the connection. And then if there is no connection, I don't do anything. But that is just masking the problem, right? Because this will work majority of the time, because you will go to your inventory page. But let's say you start with your graph page, right? You would expect that to work, but it wouldn't. It's very weird behavior. So this is not a good solution here. I simply don't know here. Okay. Yeah, I will do a shortcut here. Kind of. I don't feel like rebuilding a bunch of this stuff here. We can actually make it faster here. Thing like this. And of course this, here we should wait on this. So this will be actually be faster. I don't remember about this, so Where are all these examples though? I usually like to create tasks, but okay. I will leave it like this, but okay. And here we'll say devices is await on get normalized devices requests. And in our graph stuff, I will do exactly the same thing. Up 2020. Oh, interesting. From NetWarden models, node, import node. I didn't say this, of course. Canon import. Oh, yeah. Okay. So the way we test. Oh, I didn't fix. I think. So if this works. Okay. Maybe. Oh, it still works. It does. Okay. There are some print statements somewhere which I have to find. Print. Here. No. Here. Yeah, there is print here. Okay. This still works. Good. Okay. Nice. Now I have to change this stuff. I don't like how it looks. Completely. Okay, I need a function called Syntax error in file. What the hell? Okay, then I will do it old school way. And then you have a function called get or create connection. Okay. So what do we need to create any kind of connection? And this could be a RESTCONF connection, could be Scraply connection, could be whatever, right? We need a name for that connection. So I need a name for that connection. I need a device name for that connection. Then I need all of the parameters about that device, like what is IP that I want to connect, what are credentials, and sometimes I need a platform, and that one really depends on the library in question. Okay. Device name, connection name. Okay, then this will be connection. And this will be connection. And ideally, we would want to have to move some of these pieces around. Like this. And honestly, folks, if you have ever used Nornier, this looks to me exactly what you have in Nornier. This is why we require very specific structure in Internet, exactly for the same reasons that I am doing it right now. I would even go as far as say that connection itself should have a name. Or maybe not yet. Okay. To have this, and then if I do it, I need okay. think this should work. This should move somewhere. And then this RESTCONF. Yeah. So I guess this will also want to have plus connection error. And we do it from exception. And then here, I would want to say from NetWarden connection import connection and connection error, and then demo it. Yeah, I did. So I don't need this anymore. And I need here to have connection error, and here I have connection. Cool. So okay, hopefully this will work. Oh, actually, I broke it. Cannot import name connection from NetWarden connection. Okay, this is because I didn't save it. Cool, so now it's starting, so this should still work, which it does. Okay. So then next step would be to change this connection thingy that I have. So yeah, so I need to create these. And I'm thinking how I should retrieve these parameters. Username, password, and stuff. Okay, I will skip this for now, but we may need to get back to it in a second. So the logic there is going to be very similar to this. Okay. Yeah. Yeah, about that. This is kind of problematic here. Okay. So I want to create again general function which will be retrieving the proper connection for me from like cached connections, right? And it could be RESTCONF, it could be NetConf, it could be Scraply, could be whatever you want, right? So what do we need for that? I need to know the device name, definitely. I need to have this access to request object, definitely. I want to know what is the connection name that I'm looking for, what I want to create it with, right? And by default, it's going to be like it could be RESTCONF or NetConf, right? But what if I want to have several connections to the same device using the same library, right? For example, I want to have Scraply SSH and then Scraply Telnet, right? So then Yeah, I have to rethink this. Okay, so first I have a device name. Then here, connection. This will be, I want to get the connection first, right? And this is going to be connection name. So I want to look up, do I have a specific connection for specific device, right? And then this one could be none, right? So if connection is none, then I have to create it. So how do I create it? So I need a factory for that, right? I need a factory, and in my case, this factory is going to be RESTCONF class. So we'll say that connection is equal to factory. And using this factory, I have to provide ideally all these things in the general form. So I want to say host, and I provide host, right? So I guess what this should have is keyword argument as well. And we'll pass these keyword args here transparently. And by default, we will have host, a username, password, and platform. So if connection is known, we create it. So I need factory, and I need post, which is a string, and then I need, and this should be a callable, right? And this callable callable. Okay, I will say connection, and I have to import connection here. So if type checking, then from NetWarden connection import connection. Okay. So factory is a callable which returns a connection object, right? And then besides factory, I need host, username, and password, and platform. Technically, I do need platform. Yeah, it will need to be used everywhere. And then keyword arguments. So in case some of these connections have some extra stuff in there, I want to cover them with keyword arguments. And this will return the connection, right? So first we do this, we doing a lookup from the cache. We say, okay, let's get the connection from the request object with this device name and with this connection name. Okay, then if this connection doesn't exist, then we create one. And I guess that every connection should have a name as well here. So it will be self name. Cool. So here I get the connection for specific device with specific connection name. If it doesn't exist, then I create it. I say name is equal to connection name, host is equal to host, username is equal to username, password is equal to password, and then platform is platform. Now, I understand that not all of the connections need username and password. So in this case, we will go back here, remove it from here, and we'll add it through keyword arguments where we need them. but for now I think this factory is nice. So I create this factory, name, host, username, password, platform, okay, and then keyword arguments. So I have this connection. And then I need to save it to the cache. And this is actually set connection. Save connection. Let's do save connection, right? So in this case, I actually need that connection object. Okay, so, and I don't need this connection name anymore because we can retrieve it directly from here. So first I do get all of the connections for a specific device, right? And that could be known. So if it doesn't exist, then I will create an empty dictionary. And then I say that for this device is empty dictionary. Then I save, I will just do this, dot name is equal to connection. Cool. So this is how we save connection. So we can do save connection, request device name, and then connection. Okay. And then here we will return connection. A pretty straightforward thing. And we need to get devices, and we have to change module stuff here. So for every device here, I will retrieve device name. To share, hello, how are you doing? So yeah, I guess I will have to retrieve this piece here. So I need a device name. I need let me try doing this. So let's do this. RESTCONF connection will be get or how many functions right now? Oh, get or create connection. So get or create connection. Request. Okay. So device name is equal to this, right? And we say device name. Then I can just say RESTCONF. I can put it here. So I don't have any magic strings anywhere. So here I can say RESTCONF name. So connection name is equal to RESTCONF name, RESTCONF name. Okay. And then I need to provide the rest of this thing. So I need to have host, which will say device pop management IP, right? And then I need this as well. And I also need the platform. So platform is equal to this. That's a big function here. And on top of this, I want to cast this. If only I remembered. Okay, type and then value. So The problem here is that because you have this general interface for connections, when I'm retrieving this, I want to say that, okay, this is not just general connection, this is a RESTCONF connection. And this is a piece that will work only in PyCharm, kind of, where, so if you do this cast in VS Code, so then on RESTCONF con, you cannot do dot something and it will not autocomplete for you. But in PyCharm, if you do this, it will enable autocompletion, so that's pretty nice. But unfortunately, in this case, we will be losing autocompletion in the VS Code. So I don't think we need all of this anymore. And if only I remembered how to format. Okay, Shift Alt F. I don't see that this is working. Something is broken. 175. Oh, of course. Okay. Undefined name. Last time I felt so good when I got it to work. Now I'm looking at this and like, what this horror is? Why did I do it so badly? Okay. The good stuff here is that it seems like it's not complaining. Yeah. Okay. Rest type object RESTCONF is no attribute name. Okay, this is simply because I didn't save it. Oh, it was because of the black. Okay. Get or create connection missing one required positional argument factory. Okay. So, and I think it's here. Okay, let's try this again. I think this may work. No. Factory, unexpected keyword argument name. This should be here. Excuse me. Oh, okay. Okay, so maybe this. Yeah, okay, cool. So now I have a very generic way to store connections, kind of. I don't think it's I have some of my doubts, but I also can appreciate how it's like from one perspective I like this solution, from another perspective it's not great, I guess. So honestly, like this piece that I have right now, where is this connection? This to me feels like let me show you exactly what we built in Nornir. Now I cannot really reuse Nornir here, at least until it supports asyncio, but let me show you this. This is kind of exactly the same thing, more or less. Okay, this is plugin stuff, and then we have inventory, I think. And there's get connection parameters. You see some similarities? And then there's here connection name and stuff. Yeah, it feels like that whenever I do any kind of connection, I just save it, and it's not necessarily should be a RESTCONF connection, it can be anything. To be honest, these three functions should probably be moved somewhere. Not sure where, but in Ornier for this we have connections object, which is separate object. But yeah. Okay, so let's take a look at this LDP graph, right? And so I have devices, I do get normalized devices, and I create nodes from this netbox devices, and then I just iterate through every node. For every node, right, I guess I want to do RESTCONF connection. I want to do get or create connection here, right? I want to say that request is equal to request. I want to say that device, yeah, and this is where it will get ugly here. Because I need all of these pieces, username and password and blah, blah, blah. Yeah. This pretty much will be the same as here. It's almost copy paste. Well, not almost, it is copy paste. So I have a RESTCONF connection. So then the next piece is that I go here and I create LLDP. And then I say that for Cisco, ISXC. We will have an endpoint. This endpoint is called what data LDP interface. And then handler for that is OpenConfig LLDP parse. Okay. So then I need to create this function. And then here I say that I get again data, this dictionary of str any, and this will return whatever I want it to return. Right now it's going to be any. We will see what we will return. So this is specifically parsing piece, right? So we have to go through this and make sense out of it. Okay. So this is where the first problem appears here. Yeah, this is an issue, folks. So, damn it. Thinking what are my options here. So I need to have a reference to node object here. And I feel like that we need to pass it here. Okay. So because what I'm going to do is the following. So so for interface data, right? Where is the name? Okay. So interface name is interface data name, right? So then I have to import from NetWarden interface. I think it's in models interface, import interface. So I need to create an interface object, and this is where this problem which I just mentioned appears. Right? I need node is equal to node. How do I get this node? Especially considering that this function is being called here, right? How do you do this? So I need to somehow provide this. I either need a like nodes lookup or something, so I can look up a node. Okay, I need to find where I'm calling this handler. I think I have a function called getData or something. Yeah, getData. And I provide the key. So I think what we need here is to have some additional things. Right? So this retrieves a handler. Now I also need to look up where I see this getData. GetData. I think it was right here. Yeah, data. Okay, yeah, it's over here. So from the created connection, I say that I want to do getData, but here I can also provide another argument like whatever I want to provide, right? So then it should be as a keyword arguments, I guess. It's already getting ugly, but I guess I don't have a choice here. Or maybe there is some other better way to solve it, I just don't see it right now. So this getData, right, will have a keyword arguments, and then handler is enabled. We'll have to rework this bunch, but this handler data, this is where I pass that keyword arguments, right? And then here I will actually no, I don't need keyword arguments here, but I do need node here. Node is node object. So we'll do type checking. So if type checking, then from NetWarden models node new for node. And this will be not plus here. So OpenConfig LLDP parse node. Okay. So that now I can provide this node here. So I have it here. And to be honest, I feel like it's still better to create this interface object. So I guess I would want to say that node interface. Even though I don't, even though it creates this kind of circular dependency, but so you have it here. Okay, and then we have add interface, self checking, if type checking, then from typing, no, from NetWarden, models interface, import interface, and here interface. Actually, you are very quiet today. Feel free to ask any questions you want. It actually will be very helpful for me because honestly my brain is kind of fried already with this stuff. Okay. We may need to change this to a dictionary so I can do a lookup for interfaces, but probably not yet. Okay. Okay, so what I did here is actually quite dangerous. Yeah, it's very ugly. So the reason why it's ugly, where I call this? Yeah, we'll do like get data something. Data LDP. The reason it's ugly and it is super ugly because the following. So probably I will here. I actually cannot run interfaces. It depends. Like if I return interface, then it's kind of broken because my function says that I take something as an input and I output something. But what it doesn't tell me is that it also modifies this node object here. This is in place modification mutation of the object. This is bad. So if I want to keep this, I guess I want to do only this. I don't see any other option here. Maybe I'm overcomplicating this, I don't know. So we will do OpenConfig LLDP parse. Yeah, and this is only one piece, right? Because yeah, this is the part of the program which I'm not sure what is the best way to approach this, but the way it is right now, it's not great. I guess I can say something is not right here. Like, because it kind of breaks all programming flow here. This is another piece. So we'll have all these parallel tasks, right? Which is retrieving LDP data. But So what I did right now is that I went through this list and I created this interface object, right? But then in this neighbors thing, I'm referring to the interface of another device to which I don't have access to yet. God damn it. Because I will have to go through like this, so neighbors data. I could actually copy it from somewhere here, yes. Yeah, you can almost copy it from here. I can't believe this. I will disable music for a little bit. I need to analyze this. Let me play with my tablet right now a little bit for absolutely no reason. So what is this? Um, oh, I cannot scroll right now. So yeah, over here. So I go through this LDP data, right? And then I have every interface in the first piece. So I can create here, why it's so big? So I create an interface here, right? So I create, oh, my writing is horrible. Interface here. And then I may have a neighbor, right? So if I have a neighbor, I want to get this piece, right? And I want to get this piece, right? But remember that this is always being done in parallel, right? This interface belongs to another. This interface belongs to another device, correct? And like So I am right now doing, let's say, task for R1, right? So I'm doing this task for R1, I'm creating local interfaces, and then I stumble upon R2, and then I create an interface for that node, right? But what happens in R2 task, right? Because it will go and it will also create this gigabit 1, gigabit 2, gigabit 3 stuff, right? But that interface is being created by another task. This is my issue here. It's very ugly, super ugly. Because if I want to create link, right? So link is, well, I need interfaces, right? And those are interfaces objects. Okay. asyncio itself will partially solve this problem for me. And the reason why is that all code which is not awaited will be done synchronously. So like in threads, this would be a problem. So in threads, I would definitely need the log whenever I create interface for another object, right? So if I'm going through LDP data from R1, right? And then I need to create an interface object for R2. Then I would need to log during this piece. And whenever I create interfaces here, I also will need to get a log. Because I think I don't need logs, but it's still kind of weird if you think about it. So what do I do? So I think one of the solutions would be to go create all interfaces first and then analyze neighbors second. So like first I go on every device and I create an interface. But even in that case, this will just not work. Still, because R1 and R2 tasks are independent. Wow, okay. I can still do it if I don't convert this to objects. So if I have R1 task, right, it goes through this stuff. But then here, when it encounters this kind of stuff, I just save the strings. I don't create an objects. So if I don't create an objects, then I can do it. And then I do, what's called, reconciliation, right? I do reconciliation after all tasks have finished. So then I can go through all of this neighbor data and create stuff. Is it decent solution? I think yes. Thinking what is alternative here. So it's basically the question is create objects in tasks, right? So if I will create objects in tasks, then I'll have to care about some of these pieces of referring to other objects and accessing that data there. If I don't, then I will have to iterate through this stuff again. So I first have to iterate and create all interfaces, and I have to iterate and create all neighbors. Or I can do partial stuff. Like I can first create all interfaces as objects. So this is object part, and this is like just a list of strings, pretty much dictionaries, right? So I can do this. What do you think, folks? I don't have a good answer at all here. I feel like I want to create everything in line, but I may also regret about this decision. So if I want to do this, then if I want to create objects everywhere, then this should be dictionary string to node. Okay. Then, besides this, I need to have node name star. So I can do this piece, for example, right? So I provide LDP data and I provide a list of nodes, and then I also give a name of our node. Cool. Node name. I would even call this name template. Okay. So if there are no neighbors, I just continue. Alternatively, I go through every neighbor and then, ouch. Yeah, so this is a piece where it's going to be weird. Okay, so this is fine. This is fine. This is... This is fine. I will need this function somewhere. Then here is the biggest difference. I will have to look up the node. With this progress, folks, I don't feel like we will actually get to the diagram. We are right now just on the graph stage. Wow, didn't expect it's going to be that hard. I mean, it's kind of not hard and hard at the same time, I guess. Okay. So I create this, right? Then for neighbor, neighbor state, neighbor info, remote interface name, cool. Now here, okay, so this remote node will be named to node, remote node name. I would even say lower, so we'll keep that in the lower register, just, not to have problems anyway. So, okay, now name is a remote interface name. And node is equal to remote node. And then it somehow goes to interface neighbors append. This one, I don't know. Okay, so I think, so OpenConfig LLDP parse have this stuff, and so if I didn't do any, okay, so I'm not sure about this part. So I go and create an interface, right? And then I want to create a link. You know what, I will get rid of my hair plugs, they keep falling off my ears. So here is another interesting piece. Damn, that's hard. So yeah. So think about this, right? So if I create a link here, so whenever I see anything here, correct? So if I see anything here, I will go ahead and create a link. Is this a correct way? My problem is this, is imagine you're in an environment where, let's say it's VPLS, for example, right? And you enable LLDP on C devices. Actually, on, let's see, yeah, it's on C, yeah, on C device. You enable LLDP on C device that you tunnel across your VPLS, right? Using VPLS. So I think on one LDP interface you may see multiple neighbors, correct? Like, let me try drawing this. So you may have, so this is MPLS, right? And then here you have C1, and here you have C2, and here you have C3, right? And this is VPLS as well, right? And I already, don't remember these technologies very well, but I think if you enable LLDP here, and I think it's also can be Q and Q. It doesn't necessarily need to be MPLS. It can also be Q and Q. So if you enable LLDP here, right? So then on this interface, you'll see two LLDP neighbors, right? For that, I don't feel like we can draw it. I mean, we can think about how we can approach that use the case, but the problem is that if I go through LDP neighbors on this guy, right? First we'll see this neighbor, and then we'll see this neighbor. And it's going to be kind of broken here, right? Because it will create a link C. So it will create first link CE1 to CE2, and then it will create a link C1 to C3, right? Even though, I mean, it really depends like how you want to look at it, but here is why I if you look on my code, right, look at what I did here, right? So when I was parsing this, I just added a neighbor. I said, you know what, on this interface I see the following LDP, I see the following interfaces on another side. So this is what I did. And then later I would go through all interfaces and see where I have the neighbors, right? And where I see only two neighbors on, sorry, when I see only one neighbor, this is where I go ahead and create a link between them, which I'm going to actually draw. Yeah, now I see why I have this neighbors stuff. First it looks so easy, and then you actually do it, and then it's just not so easy anymore. Okay, so we'll create a function called add neighbor, right? And this will be self interface, and this will be an interface object. Self neighbors append interface. Ideally, this should be set, I guess. So let's make this set. And this will be add. So I add an interface. And then here I had def link from self neighbors, link interfaces. Okay. Because if I want to draw that Q&Q stuff, right, I would need to use a pseudo node. And I'm not ready to handle it yet, so I will need a pseudo node. If there are three or more on one link, then I need a pseudo node to connect them. Kind of like OSPF does DR stuff for the use Z as a graph. I did not expect it's going to be that time consuming, but well, yes, this is what it is. Okay. Yeah, I see another issue here. Yeah. God damn it. So whenever I go through these neighbors, right, I always create an interface for remote devices. This is not okay. I can't do that. I need to do something else. So I need here. Okay. So this should be a dictionary now. Okay. So if we need to add interface, so this will be interface.name is equal to interface. So interface is equal to self interfaces interface name, right? Get, because we don't necessarily have it. Actually, this is incorrect. So it should have interface name. And then it should have constructor for the interface. And so I need node as well. And so the node. Okay. So first I fetch an interface. Do I already have an interface like this created? Actually, I don't need a node. Okay. Do I have an interface like this created? If yes, so if interface is none, right? Then I create an interface and I say interface is equal to interface. I can already see how this is going to have circular import errors. Ah, Jesus Christ. Okay, so here I say interface is going to interface, and then the interface has a name. And then it has node is equal to self, right? It's referring to ourselves. And then I say self interfaces, and then I can say self add interface. Interface. And then here I will return interface. Okay, so first we get an interface by interface name. If there is no, we create one, and then we add interface using this function, and then we return interface. Okay, this is okay. So then, yeah, and then I instantly have circular import. Okay, so I need to change some of these pieces. So here, when I go through interface data, I want to use this function. I want to say that node getter create interface will be interface name. So then I don't need these two calls anymore. Okay. Second, for every neighbor, I will do exactly the same thing. So here, remote interface will be remote node get or create interface remote int name. Cool. And then I add it to the neighbors list, and this should be, I think I have a function called add neighbor now. Yeah. So let's use that. So interface neighbor remote interface. Okay. Okay, this links is not relevant anymore. Node name is still useful. Okay. And this is not useful. Okay. Let's take a look at this again. So first I get the node using name to node and then whatever. Next, I go through the payload and I say that interface name, we retrieve it, and then we get or create an interface with that name for that node. Next, we look on the neighbors. If there are no neighbors, we can move to the next interface. Alternatively, for every neighbor, we'll retrieve the interface name, device of QDN. We will find what node it is. We will do a lookup here. And then I will do the same thing. I will get or create an interface called, I don't know, whatever, gigabit 2, right? And then if all of that is done, our local interface will say that, okay, my local interface has neighbors X, Y, and Z. So now I have everything I need to actually build the graph. Now another thing that I have to take care of would be the imports here. So this import should fix our circular import stuff, maybe, which doesn't. Very interesting. So I guess, okay. So there is a circular import between these two. Why? Why it's the case? It should not be the case. So unless I do anywhere, I need to merge case. Let's see. Okay. Node. Yeah, this is a mistake, of course. So here it should be if type checking. Then we do it like this, and then it should be like this. Yeah. Okay. Yeah, and this was actually the problem. Very nice. Okay. I can't believe our controller becomes more complex and more complex. Like it's even more complex than I thought it would be. It's just very sad. But we are having a progress here. Okay, so this OpenConfig LLDP parse. Okay, so now I'm having some issues here. So I would say here that this is any, and this should be called parse. And whenever I call this, I will call parse now. Okay, so let's take a look at this graph, right? So first, this node from netbox devices should be changed. It should be now dictionary. And this is also dictionary. This is name to node. This should be a dictionary. And here Okay, this is from netbox devices. This will change here. Okay, so this is name to node. We'll probably have to work on this a little bit. I may need to create, like, I don't want to, this is a little bit too much code here. These pieces are okay. These 4 pieces, not great here. So I may need to do some data mingling, maybe create a new function here. Okay, so first I have every device. For every device, we will get the device name. Then we create a RESTCONF connection, or we get existing one. Cool. The next piece is going to be creating tasks. Parse LLDP tasks, right? Then we have to create a task. Okay, and this will be RESTCONF connection parse. And then I get a key, and I think that key was LDP. And then I provide extra argument. What? How does this auto completion works? Wait, hold on. What? Folks, I'm not sure if you understand it. Wow. Okay, this is something new, and this is amazing. Take a look at this. I haven't seen this in VS Code before. So this is RESTCONF connection, right? I cast it here to a RESTCONF object, okay? First of all, look at this. VS Code now actually understand casts. Wow, okay. So first of all, VS Code understood this cast. So if I do parse, again, if I do dot, you can see these functions, update availability, parse. There's some other stuff, but parse, update availability. If you look here, this is part of the of this RESTCONF class. So first of all, it understood what type of object it is, but then something even better happened. When I did dot parse, right? So dot parse is this function, and it says key and then keyword arguments. And I don't think even PyCharm does this. And I really cannot believe that it's doing this. Look again here. I do LDP, I do comma, and then it expands for me keyword arguments, name to node and not name str. You know where it's getting this from? from here. Like it actually dynamically resolved the this key using this dictionary. So it went here, it looked on this function and took this function signature to do an to do contextual help for me. This is some next level, guys. Unless I'm misunderstanding something, but this is like, let's do this again. So I do LLDP. Look, and it says to me, okay, with LDP you can use name to node and node name thing. But no, it actually doesn't work like this. Yeah, that would be too much. Somehow it gets the proper idea, but it gets the argument in the incorrect place. Still, some of this is some kind of weird magic, guys. Okay, so we created a task here. And then parse LDP tasks, we will append LDP task. Okay, so then the next piece will be await on asyncio together, parse LDP tasks. I need to do this. Okay, so after we do this, we already have almost everything we need. We need to go through every interface on the device and see on which interfaces we have exactly one neighbor. And on that interface, we'll create the link. So for node and name to node values, for right now, I will just print it, I guess. For interface in node, and we can create property here. So I can say property def interfaces self. This will return values view where we have the type interface, and this will return self interfaces. Actually, need to interface name to interface values, and then here name to interface and add interface as well. So this is a node. Yep. And we will say that for interface in node interfaces, if interface neighbors link from neighbors. And then I will just print this link on the screen. Okay, so this maybe will work. Okay, invalid syntax. Parse LDP task API 242. Yeah, another. Okay, now this works. So do we still gonna get the backend? Yes. And then the next piece will be 192, 168, 153, 100, 8000 LD, no, graph LDP, I think. Internal server error. Okay, get normalized devices missing one required positional argument. Oh yeah. Cool. Let's do this again. Interface object is now attribute name device name. Okay. This is some of these issues here. I guess so. Here needs some wrapper. Interface object has no attribute device name. Uh, okay. Solve node. key. Okay, so this should be node. Hash should be based on node name. The rest looks okay to me, but let's see. The next. Okay, key error R6. Aha, okay. This is interesting, folks. Take a look at this. So here's what happened. Okay. At least I like this type of error. We have to think about this as well right now. So in netbox, I have 3 devices. Okay. And yeah. Okay. In netbox, I have only 3 devices. R1, R2, and R3. We write them down as nodes. And then we go to every one of these devices via RESTCONF. Now we go, for example, on device R1. Yes. It doesn't necessarily need to be R1, it could be one of these 3. And then we can actually see which one it is. 2, 3. It's actually R3. We go to here to R3 and we fetch the RESTCONF data. Yeah, we fetch this RESTCONF data. We get interface 1, interface 2, and then on interface 3, we have a neighbor. One neighbor is router 2, which is fine, but another neighbor, where is this? It's on another interface. On this interface, we have a neighbor R6, okay? But there is no node like this. There is no node R6. So this is interesting. Yeah. So it fails on... It fails here, right? Because this R6 just doesn't exist from the netbox, and we get this name to node from the netbox. So how do we solve this? I'm thinking of creating another class called nodes. This is kind of issues which pop up all the time whenever you want to actually start creating objects, and one object is like child or, you know, somehow related to another object. You need to make sure that you have all of these objects in the first place to do these links between them. So how do we solve this? I feel like the best way is to actually have the proper nodes class, and then that nodes class will have all of the nodes, and you can do a lookup easily. And I think this will be almost it. I don't know. We are what? We are almost at 3 hours. I think I can go to like 3 hours, 15 minutes or 3:20 or something. I'm already very tired. Okay, I think we can create class called graph. Ideally, this graph should actually contain both. Actually, yes, I think we can just say graph. And yeah. So this one will be dictionary of str to typing, import dictionary type checking. If type checking, then we will import something like this, I guess. So in this one, what did I do? We also need link. Okay. So address will be list of links. I could call it links, but that doesn't matter in this case. List of link, and it should be list of and it should be proper import. Okay, so then here I can say nodes self. So this will be values view node return self name to node values. And here I can add node self node, and then this is none. I can say self name to node, node name is equal to node. Okay, dev get or create node, and this will be what we just need a node name here. Str. Okay, this will return node object. Okay, so here we say node is equal to self name to node get node name. If node is none, then node is equal to node, and then name is equal to node name. Then self add node, and then return. Okay. Okay. So here I can, instead of providing this dictionary, I can just import graph. From NetWarden, models, graph, import graph. And here I will provide graph. And this will be graph. Okay, we need to create this graph from the app. So from models graph import graph, and then in our function LDP graph. Yeah, so here I create the graph. And then I don't need this anymore. So I create a graph. And then I say here that the graph is a graph. And then for node in a graph nodes, we will do some of these things. Okay, so here I don't need this as well. Or do I actually do need that? Yeah, I do need this. Okay, so first we say node is equal get graph get or create node with node name. Okay, and then here remote node is the same thing. It's graph get or create node a remote node name. So we'll be creating these things on the fly, and this is useless. Okay. So this may help, but probably I made a mistake somewhere. No module named NetWarden models nodes on graph line 2. Okay, list is starting. Let's go ahead and do our request. Method objects not iterable. Okay, so this is a property. Still, okay. Less than not supported between instances of node and node. What? Yes. Yeah, I know what this is. So we have to sort this. So, okay. Interfaces, line 47. Okay, so less than, this should be referring to node name, of course. This, look at this. So for devices that are in netbox, which is 1, 2, and 3, right? We go to every device and we found these links pretty much between each other. I think we could change this a little bit on these links and it's like a star method. Yeah, it's a star method here. I think I could say slug here and don't. Okay. like this. So it's kind of better. Okay, so this is amazing result, guys. I'm so tired, to be honest, but I still want to get some of the results. I mean, this is already decent integration. I'm very happy how we rework connections. It's probably not the last rework, but it's still very decent rework. Okay. So I have these, and then I have a graph, and I have a nodes, and I have an edges. Okay, so I guess the next piece would be to look at the payload of this, right? So then now that we have this now that we have this, we have to build this payload, and we have to send it to the front end. This is what we need to do. So we need to send these, and we need to send these. So let's think for a second. I think we need to go back here to up. Yeah. So here we will return graph dump. Okay, so we need a function here graph dump, excuse me, and this will be a dictionary of str to any. Okay. First, this will return nodes. Okay, so nodes is the following. It's an ID and a label. Okay, so node is ID is node ID, and label is node name. For oh yeah, ouch. Wait, what am I doing? This is a dictionary. This should be a list, right? I think this is how it is. Yeah, it's a list of dictionaries. So for node and self node, super straightforward. And then the result here will be nodes is node, and then edges is edges, and then edges, you have to think about this. So another function that I think I want to have here would be calculate edges. So this will be in place. This will copy these pieces. So for a node in self nodes, we will go through every interface, and if there are neighbors, we'll create a link. Let's use a trick. So if there are no neighbors, we will go to the next iteration of the loop. Alternatively, we'll create a link. So here we have a link. And I think we can do self edges at this will be set. Self edges add link. Okay. Because this is calculate edges. So here for edges, okay, we'll go for edge in self edges, and we need to create this thing, right? So from this will be I guess it's better to have links here. So for every link in self links, if link is point to point, right? If link is point to point, okay, then we will do this thing. Okay, so from and I need to refer back to here. And I think another thing that we should do here would be property first interface return interface object. So this will return self interfaces 0, and then property second interface. The reason I do this because I don't want to have magic indexes anywhere. Second. Okay. Cool. So from will be link dot first interface node ID, then 2 is going to be link second interface node ID, and then we need a title. And this is going to be I think I can just use link str like this. Okay, and this will be returned as the dictionary current result. And I think unless I missed something, okay, I may need to, oh, there is this app here. Okay, so graph calculate links and then return graph down. Okay, there is some errors. Has no attribute edges. Rough. Oh, cell here. Edges line 26. Links. Okay. Still a problem. Not object is now attribute ID. Okay. Oh yeah, of course. Okay. Cool. Look at this. So we have these nodes. We have 6 of these nodes. And then I have an edges between them. Okay. We are at 3 hours, 80 minutes. Okay, I guess I can stay for like 10 or 15 more minutes because we are so close to actually building a diagram. Because we have data in all of the proper ways, really. So we just need to add the components here. We will be done. Okay, so now it's pretty much copy paste here. And I think I need to also install some stuff. Okay, so this network and view Vue.js. I think I need these two. Let's start with view Vue.js in this network. Okay. So yarn at this network and this view Vue.js. So this will be added as dependency. Second, I need to change a route here, right? I need to add, well, first I need to add a view. So let's do network diagram view, the same thing. Network diagram view. Okay. And I will just copy paste this thing. So we need now a component called network diagram. So network diagram view. And we copy paste it from components. We have to change some stuff here. Okay. I think for like first example, I can leave the static data. Once we fix stuff, we'll change this. Because here we'll have to do a function which does an API query. Like we have here in the inventory, the Axios, the same thing. So for now, I will just leave it like this. One thing you need to count. Okay, so I have this component. This component is being referred here. Then, do I need to register? I don't think I need to register anything. No, I think we are good. I think I can just add here page. So we'll just do diagram. And this will be network diagram view. From import network diagram view from network diagram view. Okay. So now task frontend. So if I did everything, oh, I didn't do everything correctly because I need a menu, right? So I need a menu. Where is this? Oh, here? Yeah. Okay. So if I go here, okay, so I have a diagram. So this is the static data. Okay, now we change this data here. Okay, so I need, let me do this. Split right. Okay. This is in the component. Okay. First I need to import Axios. Then I need to get rid of all of this. So you have nodes is empty and edges is empty. Okay, then options can be whatever, I don't care. And then here we need mounted. Mounted Axios, and then graph LLDP. Then I don't need console. And I just need to say this nodes is equal to response data nodes, and then this edges is equal to this response data edges. Okay, so hopefully this was correct, which it wasn't. Okay, why it could be the case? Did I save this? I did. I get here correct data. So let's just recompile frontend here. Okay. And then look at this. Wow. So this was just built based on LLDP data. So let's take a look at this. So 1 is connected to 2, 2 is connected to 3, 3 is connected to 6, and 1 is connected to 4. So it's 4, 1, 2, 3, 6. Yes? So 4, 1, 2, 3, 6. Awesome. And the only reason why we don't see the rest of the topology is because I don't have it in the netbox, right? So if I had it in the netbox, then we will see more of this topology. So let's go ahead and add more devices and we will wrap up the stream. Okay, so I need now router 4, should be Cisco, CSR 1000V, no serial number, site doesn't matter to me, status active, platform ISXC, and then Let's do create and add another. So this will be router 5. Site Amsterdam. Right now I don't care. Yep. Create and add another. And then we will, let me look on the diagram again. Let's say, yeah, let's just leave it like this. So we have these 5 devices, 1, 2, 3, 4, 5, right? And then they should see 6 because 3 will see 6 and 5 will see 6. So this will be this part of the topology. So yeah, I think this is good. Now we need to add secrets for those and IP address. Now my only thing is that I don't really remember how to do some of this stuff. So I think if I add it, no, is it secret? Oh yeah, okay. So I need credentials here. Wait, why doesn't allow me to add here? Or secrets here. Okay. So login credentials, it should be Cisco. Okay, and then enter your private RSA key. Great progress today. Yeah, EML, I agree with you. It's I'm very happy, even though it took much longer than I thought it would be. But I thought that actually making it work with the front end, it's going to be much more work. But in the end, it was just copy paste. The majority of work was to do proper Python logic here. So I need an RSA key for this one. Okay. So I need to create another. I can cancel. Okay, 5 secrets, credentials, Cisco, create. Okay. Then next I need a management IP address, and I don't remember what this interface is. Name. Here I think I need to be very careful with this. I don't remember. This is 1GE. MTU description, no. Management only. And then I think here, add IP address 192.168.133.104 /24, status active, role, no role. This is management. I think I need to put this in management VRF. I don't remember. Cool. And then I think this is it here. So yeah, let's check if that interface is in VRF. Okay, this is management VRF. This is management VRF. This is not in VRF. Okay, I don't think it matters that much, but let's fix it anyway. Here I think. Yep. Management VRF. And then 4 is management VRF. Okay, so now we need one more. So 5 and interfaces. Gigabit Ethernet 1. Gigabit. Gig. Okay. Management only. create, and then I need an ending IP address 192.168. This will be 105. Active role VRF management. Make this primary IP address, and that's all. Okay, so I have here 2 more devices. Okay, now first of all, let's go here. Okay, so something breaks here. I'm very curious what, and I think, yeah, remember, this is not the first time we see this. So something about secrets works somehow weird. I remember that I was not changing anything and then it just started to work. Okay, so now I see 5 devices with their serial number or with their software version. Now, moment of truth. If I did everything correctly, now we need to see 6 devices in a circle. Yeah, let's go. Let's go. Let's go. 1, 2, 3, 6, 5, 4. 1, 2, 3, 6, 5, 4. And all I did to add new devices here to the diagram was add them here with their IP address and with their credentials. Yeah, this is. Thank you, Meow. I also like this progress. I feel good. I feel good. Okay, 3 hours 35 minutes. Yeah, that's quite a long time, especially considering we started 1 hour 20 minutes late. So yeah, let's do a wrap up. So today we were continuing working on this NetWarden controller, and the main focus today was doing do network diagram based on LLDP data. My idea was to do one on LLDP and one on netbox data. LLDP is a little bit harder, obviously, for obvious reasons, but whatever. And I thought it's going to take less time, but of course it didn't. The problems were kind of surprising to me where they appeared. Like the most time consuming part was not to rework completely how connections are handled in my applications, in my application in particular. And I feel like I will need to rework it a little bit more to like separate this in its own class or something. So probably I will create a new class called connections. So I had to rework this, and I had to create this get or create connection. And this is very similar to what Nornir does. Very, very similar. So the idea here is that you say, okay, I want to have a connection for, let's say, R1, and it should be a RESTCONF connection. So this is what we are doing here. We're saying, okay, this is, let's say, R1, this connection name will be RESTCONF as a string, and this factory, this should be a class called RESTCONF, so like here, right? And then I also add this, what we call in the Nornir, we call standard parameters, right? Like hostname, username, password, platform. So what this does is that it gets these details from the netbox, host, username, password, platform, and then provides this to this connection factory, right? So we create this RESTCONF connection and we save it for the whole duration of the program. So reworking this took quite a long time here. And then another thing, we had to create a proper object model for the data. So we already created RESTCONF integration last time, So what I did here was, man, I just can't find it, of course. We added here a new handler for LLDP, for asyncio, and we provided a pass and we provided a handler for this data. This handler was like, we had several iterations of it, and I had a lot of problems with creating proper model, but I think now it's fine. So first of all, we create a graph object outside of this function, and what we are doing is that we go through every device and we get LLDP OpenConfig data. First of all, if the device doesn't exist in the graph, we create this node. Second, for every interface, if it doesn't exist, we create this an interface. Third, for every neighbor, we create a remote node and remote interface, and we save this as a neighbor on that interface. So we say that, okay, on my local interface, I see one or many neighbors, or 0 or 1 or many neighbors. So I add this. This is what this parsing function does. So for example, if I were to use different handler, right? So let's say my device doesn't support OpenConfig. So what would you do, right? We could create another function which will retrieve this data. Let's say it will retrieve CDP data and not via not via RESTCONF, but via SSH, right? So you would create here another handler. This will require a little bit of rework because we want to specify that, okay, this is for RESTCONF, you can handle it like this, but for SSH, we will handle it differently. So I have this function, and that function needs to do exactly the same thing as this function does. It needs to go through, needs to create nodes in the graph, and parse through all interfaces and create remote interfaces. Do exactly the same thing. But it's totally doable, and I actually feel like this would be a very good example to do next time. We can even start implementing this logic where I want to get some data, but this data could, let's say on one device will disable RESTCONF, right? And I still want to fetch the data. So how would I do that? I'm actually thinking that would be a very interesting example, like how to mix RESTCONF with SSH or something like this, how to fall back to SSH. So we do that, we create this, we fill in this graph object, which I cannot find anymore here. We create these nodes and we create these links. Actually, this is not what we do. We create nodes, and then there is a function called calculate links, which will go through nodes and create links where necessary. And then lastly, what we do is that we create an API endpoint here, /graph/LDP. Maybe it should be a parameter, I don't know. I don't care right now. And we use this function, and we're doing it using asyncio create task, and then using asyncio gazer. We do this all in parallel on all devices, right? Then after we do this, we calculate links on the graph, and then we return the graph in the format that our JavaScript understands. And then using this.js, we render it. Now, let me reiterate this one more time. This is a live diagram. I mean, it's not live updated, but whenever you refresh this, this is built live based on LLDP data. Okay, so it's not, right now it's not even cached. So it takes what, 1.5 seconds to build it? I feel like it's quite amazing. We will, probably next time we'll do several things. We'll add all 10 devices here. for the visuals. And next thing is that I feel like we need to work on this RESTCONF/SSH integration. So let's say RESTCONF is not enabled on the device. How do we handle it in our controller, right? Because we want it to be robust and all of that kind of stuff. So how do we do this? So I feel like that would be super interesting to see next time. All right, or maybe I will select something else. I don't know yet. I think we did a lot of cool stuff today. I hope, folks, you found it interesting for you. It was definitely interesting for me to do this. I'm happy we did it. Yeah, with that, thank you so much for joining, and I will see you next time. Goodbye.